Anybody know where these questions came from? These are the 5 most missed. Most of them are well under 50% correct. Several of them are in the 30% correct. Notice anything about number 2 and number 3? There's just gross memorization. I was a little surprised that only 30-some% of you got those right. Very surprised. All right, at least 4 and 5. 5 is at least a calculation. 4 required some thought, and I can understand why some of you were confused. 2 and 3, I was just stunned. Stunned. All right, tell me about number 1. What does it mean to be extensive? Does it depend on size? Yes. Okay. And I don't remember what the question had for an answer, but what would you have been looking for there? Give me some examples of things that are extensive. Mass. Something else. Length. Weight. Volume. Height. Any of those would have been good answers. Okay. Number 2. Which of those is the exception? Who's not an SI unit? Liter. All right, what's the SI unit for volume? Meters cubed. Okay, liter is not an SI unit. All right. Number 3, the SI unit for length and mass. What's the SI unit for length? Meter. What's the SI unit for mass? Kilogram. If you got 2 and 3 wrong and lost points for those, I would say you didn't study for the test. Number 4, these are the unit or the numbers that were obtained for mass. Are they precise, accurate, both? Neither would have been the answers. So, what can you tell me about those numbers? No. They're precise. All 3 answers are 7.8, so they're precise. They are not accurate because the right answer is 7.0, not 7.8 or close to 7.8. So they are precise, but they're not accurate. All right, how do we do the last one? You want to tell me? This one was right at about 50% right, so at least half of you know how to do this. So the half who got it right, somebody out of the half knows how to do it. We shy. Everybody else is absent. I don't get any volunteers. What do I have to do with the mass? Gotta do what? Convert it to kilograms. Because the question told you that it's in SI units. You have to do what? You have to change it to kilograms. So 4.89 grams has to be changed to kilograms. So 4.89 grams to kilograms. 1, how many spaces between grams and kilograms? So 3 zeros and a 1, we get 0.00489 kilograms. Then you have to take your...
Teachers, bus 331 has just arrived. Please allow those students into class.
Your centimeters cubed and change centimeters cubed into meters cubed. Which one is bigger? So 1 meter, 100. What do we know about meters cubed and centimeters cubed? So cube the numbers, and we're going to get if you left it like that, or 1.267 times 10 to the negative fifth meters cubed if you did that. Now, once you have those two numbers, you have to find the density. So density equals 0.00489 divide 1.267 times 10 to the negative fifth, and you can get an answer. Questions about how to do either of those two? The kilogram or the meter cube conversion, and then finding density. Now, overall, I was pleased with the test. I'll go grab the test and the answer sheets so that I can hand those out, and then you guys can look at them. Staple them together. All right. We send out Annette, Karina. I think that was it. I think everybody else besides who didn't take it was still out. Let me see. Who knows everybody in here? Who? Here, I know that. If they don't have a name on them, see if you can figure out who had a test paper too. Alex is not here. What's it look like? Molly. I don't really know that it says Lolly. I just recognize the bad handwriting. I don't really know what it says. Okay. I know it starts with some letter. Looks like an S, to be perfectly honest with you.
It does. Honestly, that looks like an S. Okay, maybe.
If you say so.
If you
It
erase
really
this
looks
part,
like,
maybe it looks like an S.
I was going to say, that is not an S. But if you want to pretend it is, okay. You can see how that's an L?
I can't know.
Okay. But on initial looking, it does not look like an L. Okay. Put that one up there on my desk. I was thinking they were answer sheets myself. All right. Now, if you've not seen these answer sheets before, okay? I know Angel has because he's taken a class with me before, so he knows how they work. Because I know a lot of teachers won't print these because it's extra paper, so they just call out answers and things. I'll borrow Angel's for a second. This is essentially what the phone took a picture of your original sheet. Some of them will be really blurry because I scanned them really fast, and my hand shakes now that I don't have one hand. I'm getting better with your hands. So this is what you want to look at here, okay? The first answer under PRI is the correct answer. The STU is the answer you bubbled on your answer sheet, okay? PRI is correct. STU is what you marked. If you look at the column that says question mark at the top, it has an X or a C. C means correct, X means wrong, okay? So if you look down the column and you see the ones that have the X's, those are the ones you got wrong. And the PRI is the correct answer, so you can see what the answer is supposed to be. Okay, does that help? Figuring out what the answer is supposed to be. Overall, the test scores were very good. Okay, I was pleased. Now, I still say you can have test corrections on this test. There's only one person who doesn't need them because they got 100. Okay, everybody else can have test corrections. If you made a 93, if you want to get up to a 90, that'd be 7 points. Half of 7 points would be 3.5, which would round to a 4. 93 plus 4 would be a 97. If you want to do that, you are eligible to do that. If you have a 60 and you want to try to get an 80, you can do that. It works both ways. You do not have to have a low score to only do test corrections. You can have a high score also. If you are perfectly content with your 84, that's A-okay with me. I'm not pushing anybody to do test corrections. It's more work on me. But if you want to do them, I told you I'd give them to you. You're welcome to. All right. I think a 79.8, which rounds to an 80 for a first test. Pretty doggone good. So I'm content with our test scores. But if you want test corrections, I promise them, I will give them to you. Okay. I have Tuesday this week. I can stay to no later than 4:15 on Wednesday, and I can stay on Thursday. Okay. And I have third lunch. Third lunch is always available. Questions on anything? Now, if you do test corrections, I have a form. It's a lot like Ms. Powers, except I expect more work probably than she does. All right, so if you missed question number, this was which one? Let me see somebody's test. This was question number, where is it? 37. So if you're one of the roughly 50% who got question 37 wrong, I would expect to see all of that in the box for question 37. If you don't show me all of that to correct question 37, I won't give you your points back. Okay? You have to show me how to do the question correctly if it's a math problem. Okay? Now, if it's one like question number 9, all of these are SI units except. So if you look at number 9, where it says the SI unit one, you would have to go through and say a kilogram is the SI unit for what? Mass. And then second is the SI unit for what? Time. And Kelvin is the SI unit for what? Temperature. So liter would be the SI unit for what? Nothing, because what's the volume SI unit? Meters cubed. You would have to give me an explanation as to how you know it's not liter. Okay? There has to be an explanation. You can't just say, I bubbled it wrong, I didn't study, I bubbled the right answer on the test. None of those are going to get you points. Or you cannot say, the SI unit for volume is not liter. Really? I know that. I told you the answer. I gave it to you on the answer sheet. You have to tell me how you know it's not liter. Okay? The whole idea behind test corrections is you giving me information that says, okay, Ms. Walt, I know it's not liter because I know these things. Okay? So you choose. Now, is there anything on the test you're just dying to know that you got wrong and you can't live another moment without knowing because you just, it's like, dang, why did I get this wrong? I don't know. Anything? While you're looking, why don't you staple your tests to the bottom of your test record, though, your answer sheet, so that when you pass them up, nobody sees your test score. But feel free to ask questions while you're doing that. Anybody? So, nothing you got wrong stands out that you want to ask about today? 19. All right, so when you look at the graduated cylinder, it's reading the 10s on the outside, which means it reads the ones place, right? So you can read 41, 42, 43. So it's between 43 and 44 because we're reading bottom, right? So if we're reading the bottom and it reads 43, you get a guess. So the guess is between 43 and 44. So 43 point what? Okay? Remember when we did the guesses? So if you know that this is across about there, you know 43 point, you get a guess. 43 point what? Okay? And that's why we only picked one place behind the decimal. because it reads in the ones place, we only get a guess in the tenths. You would get 2 places if it read tenths, and your guess would be in the hundreds. Okay, anybody else? Anybody else? Any questions? We will have a benchmark. We will see some of this again. I make up the benchmark unless the new superintendent changes things. Because there's the density of a, you thought that was density, so you put that in density. That's just grams, so the grams should go for mass, and you would just say mass divided by volume, because it wants the density of the volume. So you put the number in the wrong place. All right, who else? Anybody else? So nobody else has a question? All right, well, they're finishing stapling. This side's done. Let me have those back. I think they're big ones, since it's almost hanging up. You're getting there. Question? Yeah. Okay. Thank you, Madeira. All right, somebody let Karina and Annette in before I forget them, and I've left them out there the whole class period. That has been known to happen. Right here, Alex. Leave them out there. Don't make no difference to me. I don't give a rat's behind if they come in or stay. All right, today we're going to do something that for those of you who had a good middle school experience is largely going to be reviewed. For Angel, it's going to be entirely reviewed. All right, for those of you who had a sub, it's going to be Greek. For those of you who had a good 8th grade background, it's going to be reviewed. So you're going to have to bear with the folks who had a sub. So those of you who had Miss Cologne, this is going to be reviewed. To a point. Because she did all the stuff on atoms, but she probably didn't do the stuff with ions. And I don't know if she did the stuff with various notations.
She did it like the beginning of the year.
Well, it'll come back. It's not gone. It's just recessed in your files. So we need to pull it back out of your files. All right. So, several years ago, probably about 6 now, the state redid the curriculum, and they took out all of the history of the atom and how it was discovered in terms of the nucleus, the protons, neutrons, electrons, and all of that stuff. So now I have also eliminated it. Be thankful, because lots of teachers in this county do not eliminate that, and they still teach all of that stuff. Now, first of all, tell me what an atom is. Someone out there in student land. Anybody? The smallest part of what? Sorry, that grimace was not your definition. That was my hand. All right. The smallest part of what? Okay, it's the smallest part of an element that can exist independently. Now, once you break an atom down, you're no longer part of that element. We refer to you as subatomic particles. And most of you, if not all of you, can tell me about subatomic particles. Even if you did not have Miss Kalam, you can tell me about those, because even if you had a sub and read about it in the book, the sub would have reviewed the subatomic particles with you. Okay? So, oftentimes, we refer to the 3 parts of an atom. We're not going to in here, but just because that's a nice jumping off point, because people remember that when they come to me, tell me what the 3 parts of an atom are. Yes, okay? Everybody always remembers proton, neutron, and electron. And I would even be so bold as to say, y'all remember the charges without difficulty. So tell me the charge on a proton. Yep. Neutron? Yep. An electron? Yep. So, given that, you are going to see me abbreviate proton P with a plus, neutron N with a little 0, and electron E with a minus. Okay? Because I'm going to get tired of writing out those words all day today. And all semester long, to be perfectly honest with you. Now, one thing I would say to you, given all of you are college-bound folks, you need to learn how to shorthand some things. If you don't already have a system that you use to shorthand some words, you need to learn that. Okay? Lots of professors post notes online. Some don't. Lots of you will attend class and take notes. You need to learn how to shorthand your own writing. Now, I'm giving Lolly a hard time about her handwriting, but if you can learn to shorthand so that you don't have to write every single letter or word out, it makes life a little easier on you to write faster. Most of you don't use cursive, so you print. Every time you have to pick that pencil or pen up from the sheet of paper, it slows you down. It took me years to figure out why on earth students took so much longer to take notes now than they did years ago. The reason is we wrote in cursive years ago. There was a flow. We could go faster. Y'all don't write in cursive anymore. Y'all pick your pens and pencils up a lot more often than we did. Learn to shorthand some things. These are ways that you can shorthand things, okay? It just takes longer. So you've got to find shortcuts as you take notes. It doesn't have to be the same shortcuts I use, but you need to find some shortcuts for yourself, okay? Now, when we're in science class, particularly chemistry class, we don't refer to it as the 3 parts of the atom. We talk about the 2 parts of an atom. This is where, if you had a decent background in science, which I'm sure Ms. Kalan did for y'all, and you have some memory, you remember this. This is where it gets a little harder. You got to pull on those files from 8th grade. Okay? And if you don't remember, it's going to come back to you. Does anybody remember the 2 parts of an atom? Yeah. I don't blame you. All right? The electron cloud and the nucleus. Okay? Now, those 3 parts have to fit in those 2. Now, this is my pet peeve and where I get on my soapbox. Because it drives me crazy when people get this wrong on a quiz or a test. Now, those 3 parts have to fit in those 2, right? It's called the electron cloud for a reason. The only thing that lives in the electron cloud is what part? Don't get that wrong on a quiz. Y'all are in honors chemistry. It drives me crazy when people get it wrong in physical science. You get it wrong in chemistry class, it sends me into orbit. Okay? It's called the electron cloud because the only thing that lives in the electron cloud are electrons. It's not called the proton cloud. It's not called the neutron cloud. It's called the electron cloud because the only thing that's found there are electrons. Does that make sense? So when I ask what charge the electron cloud has, what charge does the electron cloud have to have? Negative, because it only has electrons, right? Okay. Now, if I ask about the nucleus, what charge will the nucleus have? Okay, let me ask you this. Since we have some dissension in the crowd, what particles are found in the nucleus? I just want to know the particles. We'll talk about the charge in a second. Protons and neutrons. All right, now, Caroline said that it was positive and neutral. Change that color to positive. Now think math class. So now if I ask what charge it has, and y'all say positive and neutral were the 2 charges it has, think math class. What charge would the nucleus have? There you go. Okay? So the nucleus would have a positive charge. So if the nucleus is positive and the electron cloud is negative, what happens if you have a positive and a negative charge? What do they do to each other? That's right. So an atom is electrically neutral. Okay? The nucleus and the electron cloud's charges cancel each other out. Now, notice I said an atom is neutral. If I had my agenda up here and I could hang onto the wall, I think I'm going to get there in another week or so. I'll be able to write the agenda up. I think my hand may work enough I can hold on. I can almost hold a full water bottle now. So, I know that's a big step. If an atom is electrically neutral, an ion is not. Did y'all talk about ions when you were in 8th grade? Yes. Yes. Did y'all learn to find protons, neutrons, electrons with ions? No. Okay, that was the part I wasn't sure if y'all would do in 8th grade. I know y'all would have done atoms. All right, everybody there? All right, so let's talk about this. I'll make a little handy dandy chart. Except my chart's not going to look too nice. All right, let's say particle here. Let's put proton first, neutron second, and electron last. We'll go ahead and put in charge because you guys know that one. And then we need to put mass over here because that's the one y'all don't know. All right, so if we have a charge for a proton, y'all said it was positive, right? We want to assign it a number also. So if we assign a proton a number, what number would we give it for positive? Okay, so we're going to say +1. All right, so what number will we assign a neutron? Okay, and an electron. Okay, now for masses. All of these particles are incredibly tiny, first of all. And they have numbers of like times 10 to the negative 28. But we need to give them a relative mass because you guys have learned about atomic mass and atomic number on the periodic table. And so they are assigned a relative mass so they can compare each other to other elements on the periodic table. 2 of these particles have masses that are approximately the same. So who has a mass that is approximately the same? Any ideas?
Electron and proton?
Not quite.
Neutron and proton?
Yes. All right. A proton and a neutron have approximately equal masses. Okay, so that's why they're given masses of 1. Now, an electron is sort of special. An electron's mass is so small, it is negligible. There. Now I think my letters are unattached. Okay? An electron's mass is so small, its mass is negligible. Now, what does the word negligible mean? What does the word negligible mean? Anybody know? That's right. Not important. It doesn't count. So, let's say Jaden's at the doctor today, right? Y'all all go to the doctor, right? What's the first thing they do when the nurse calls you back? Check your temperature and your what? And your weight. Now, my doctor's office has a scale where? Where's your doctor's office have the scale? Out in the hallway. So, when you get weighed, what do they make you take off? Shoes. You're lucky your shoes. Mine don't even make you take your shoes off. So, we don't all take our clothes off, right? Because every time we go to the doctor, what do we have on? Thank God. So, when we get weighed, today, I have on pants and a shirt. So, if I went to the doctor today, I've got on pants and a shirt. Last time I was at the doctor was, I think in August. Might have been July. No, I went in August. All right? So, I had on what? I had on shorts. Is my weight going to change significantly because I had on shorts and a shirt versus pants and a shirt? No. Okay? So, I don't have to take off my clothes because the difference between having on shorts and pants is negligible in the doctor's eyes. Okay? My weight might change by ½ pound. Does that matter? No. So when we compare the mass of an electron to the mass of a proton and a neutron, its weight or mass is so small, it's not important. So we give it a mass of 0. Now, when I write this 0 up here, I'm not saying that an electron has no mass. I'm saying the mass is so small, it's negligible. Okay? Does that make sense? All right. Now, from there, we're going to move into actually using atomic masses, atomic numbers, and calculating protons, neutrons, and electrons. Now, this is where, if you had a good experience, things should come back to you pretty easily. So, somebody tell me what they remember about atomic number. Remember anything?
That's how many have electrons?
Close. No.
Protons.
Protons. Okay? It's the number of protons in an atom. Okay, so atomic number tells protons. The atomic number tells protons. Okay, atomic mass. Some people like to call it mass number. You will not hear me refer to it as mass number, but it's often on worksheets as mass number. I will almost exclusively call it atomic mass. All right, anybody remember what that tells us? I'll tell you it's a combination of two things. Yes, okay. Atomic mass is the number of protons and neutrons in an atom. Okay, so mass is protons and neutrons. Now, which particle is left out of the definition altogether?
Electron.
Now we're going to find some electrons. It's not in the definition. All right, hold that subtract thought. We'll come back to that. Has nothing to do with subtraction. It's easier than that. Any ideas? It goes back to here. Something on that page.
What numbers is positive or negative?
Yes, sorta. You're on the right track.
Like if the mass is negative, it's got electrons.
Mm-mm.
You looked at the electron.
Mm-mm.
Is electrically neutral.
So how is that important if I say it's neutral?
That means the amount.
The who's got to be equal?
The protons and electrons have to be equal.
Protons and electrons, because the neutrons have what charge? They're neutral, so they're not important. Okay? So, when I get here, if an atom is neutral, the number of protons, which have what charge?
Positive.
Positive, equal the number of electrons. So an atom can be neutral. Now, here's the problem we have. Once I tell people this, that the number of protons equal the number of electrons, they come back up here to this definition that says the atomic number, and they want to say, oh, protons and electrons are the same. Can I say the number of protons and electrons in an atom? What's the word and mean in math class? Combine or add, right? Can I add these two things together? No, you cannot add the word and in that, okay? Now, subtract. Somebody says subtract. What are we going to subtract to find? Because y'all remember subtraction. So what were you subtracting to do? Okay, so what would subtracting do? So if we take the atomic number, okay, what did the atomic number tell us? Okay, the atomic number told protons. And the atomic mass told us what? Number of protons and neutrons. All right, and y'all said subtract. So what's going to happen if you subtract them? You're finding what? Yeah, because protons do what? So you're going to be left with neutrons. So anytime you want to find the neutrons, you say mass minus the number. That's what y'all are remembering with subtract. Y'all are subtracting. Y'all are remembering that Miss Kalon said to subtract mass minus number because the protons canceled out. That's what's popping in your head. Okay? Is that coming back to you? Sort of. Stella's going, no. Those are the pieces I was hoping you would recall. Hoping. Now, the notations, I have no idea if she taught. Okay? A lot of middle school teachers don't teach the notations. They just teach how to use the periodic table. So, if she didn't, it's okay. I would be shocked, really, if they did. All right, everybody caught up?
Wait, what does that mean, mass minus number?
Take your atomic number, take your atomic mass, subtract your atomic number, and you'll be left with the neutrons. I'm getting ready to show you how to do it. All right, everybody caught up with me? All right, let's talk briefly about the periodic table. All right, so let's just take sodium, Na. Which number is the atomic number? Okay, why'd you pick 11? Okay, so this periodic table over here has the 11 in the bottom. That periodic table over there has it in the top. So, how do you know which one's the atomic number? It's what, Annette? Okay, Annette says it's smaller. Why would the atomic number be smaller? It's what? Exactly. Okay? Now, you can never, ever write this down to get this as credit on anything I will ever, ever, ever give you. Okay? Atomic number is always the smaller number. Okay? The answer that Karina gave you is exactly right. Because atomic mass is a combination of two things, it's always the bigger number. So when Annette said the 11 is the smaller number, it has to be the atomic number. She was correct. Okay? It doesn't have anything to do with the placement on the periodic table. Atomic number will always be the little number because it only has how many particles in it. It only has the protons. It only has one number. So it's always going to be the smaller number. The atomic mass has two particles in it. It has protons and neutrons. It is always going to be the bigger number. Does that make sense? So when you look at the periodic table, it does not matter its placement. Okay? Now, the orange table that I just handed you is an identical replica of what you're going to get on the exam, except that it'll be twice as large. It'll fill 2 pages. So the blue charts that I gave you will come as a booklet on exam day. When you open the middle, that periodic table will fill 2 pages. I just shrunk it to fit on 1 page. Okay? So it will look exactly like that. However, when you look at a periodic table, for those of you who are planning a career that may take you into a science class, your college professor may not give you that periodic table. So atomic number does not have to be in the same place. Atomic number is the little number. Does that make sense? Okay, that's mass. Now, the symbols are based on Latin names. So, Na is sodium. It's not SO. The vast majority of the elements fit what you would expect. So if you looked up phosphorus, it's a P. If you looked up fluorine, it's an F. But you do have some like potassium. Potassium's a K. Okay, silver. Silver's a G. There are some that are different from what you would expect because they're using their Latin names. Now, when we start naming, and I'm going to say this again on Wednesday and Thursday, there's a periodic table there, and I let you use one every single time we do something. If you use the wrong element or symbol, it's just wrong, okay? There's no reason for not knowing the symbols when I give you access to them. So make sure you look up the masses correctly. All right, the two notations we're going to use. The first one we're going to do is called nuclear symbol. It's the one y'all like, because it gives you all the numbers. It's not the one I like because it's a pain to type. All right. Nuclear symbol notation has both numbers given to you. Gives you the symbol, and it gives you both numbers. So when you look at that, what is the 26?
Atomic number.
That's right. All right, this right here is the atomic number. What is the 55? That's the mass. Now, we want to be able to find the number of protons, the number of electrons, and the number of neutrons. So, what have we already said about protons? Protons come from what? What did we say?
Atomic number.
Protons are the what? Everybody here say it? Protons are the atomic number. So, protons equal the atomic number. So, our atomic number is what here? So, the number of protons are 26. So, if I cruise back for a moment, for electrons, not quite far enough. How do we find electrons? Protons equal what? Protons equal electrons. So, electrons are the same as the protons. So, how many electrons will there be? There will be 26. Now, to find neutrons. Neutrons, we do what? We subtract. We subtract what two things? Mass minus number. So mass, subtract number. So we take 55 minus 26. And we get 29. Questions? Questions about how I did it? Yes, no? No? Do you want to do another one? Yeah. All right, let's say that we have antimony. All right, antimony. What was Fe? What we just did? Iron. Okay? Antimony, Sp. That's a 51 and a 122. Okay? So, protons. How do I find the protons? Okay? It's the atomic number, which, to quote Chris, is the little number. So, how many protons do I have? 51. Okay? My electrons. How do I find my electrons? They're the same as the protons. So there would be 51. All right, how do I do the neutrons? Okay, subtract the mass minus the number. So that's 122 minus 51, which would be what? 71. Questions? Everybody with me? Devontae? Sure, if you want to use the hall pass. Yes, no? Take the vest. It's on the back side of the door. Oh. What's that? You didn't see the vest. All right, everybody got it? All right, the second notation, the one I like, one that's easy to type, it's called hyphen notation. So let's say that I pick, I don't know, let's do an easy one. Okay, sulfur dash 32. All right, what's different about this one? Only has one number. The only question is, what number is it? Is it the atomic number or is it the atomic mass? It's mass. Okay? So, this right here is mass. What are we going to do about that? I finally gave you mass. What'd you say on Maja? You're not wrong. Say it. Yeah. And where do you find it? Yeah. Okay. So, we look up the atomic number on the periodic table. So, what's the atomic number? All right. Now, the reason we can do that is out of the atomic number and the atomic mass, which one never changes? Right. Atomic number never changes. Okay? I can change atomic mass all day long, but I cannot change the atomic number. Okay? Now, when I change the atomic mass, it's called an isotope. Anybody remember that word from Miss Kalan? Remember the word isotope? Remember the word, just have no idea what it means. We'll talk about that in a minute. Okay? All right. Everybody caught up? So, if we have 16 and 32, all right, the number of protons. How do we find the protons? What did we say it was right here? It's the atomic number, right? It's still the atomic number. So what's the atomic number? 16. It's exactly what Elijah told us to look up. All right? The electrons. What do we do to find the electrons? It's the same as the protons. What's the protons? And to do the neutrons, we do what? Okay, mass minus number. So we have what for the mass? And that's one of the rare ones that turns out to be the same for all three. Very rarely will you get the same for all three numbers, but sometimes you do. Okay? Questions about that? Yeah? Seems pretty easy, doesn't it? Okay. Do you think we can work backwards? Yeah? It's not hard. It should be largely reviewed. I know it's recessed in your files, but once you practice it a little bit, it'll come back. Sailor's going, it's not recessed in my files. I've never seen this before in my life. Do you have Miss Kalan? Okay. You just don't remember it at all. It's a blank slate. Okay. Diamond, you don't remember it either? No. It's okay. We'll practice it some more. All right. So let's say that I give you 42 electrons and 50 neutrons. Okay? And we want to write what we just did. What things can we figure out from that information? Okay? How can we figure out the mass? Okay, so if we're going to add the electrons and the neutrons, what leap have you already made in your head? You've already made the leap that electrons are the same as protons. So how many protons do we have? All right, so Annette's already made the leap that there are 42 protons. And she's already said that we can add the protons plus the neutrons to get the what? That will give us the mass. So 42 plus 50 is what? 92? So we have a mass of 92. Now, that's the mass. What do the 42 protons tell us? That's the atomic number. Now, given we have the mass and the number, can we write the two notations? Yeah. So, what do we need to figure out to write the notation? The what? Yeah. All right, so which of those two numbers tells us the element? The number does, right? So, what element do we have? It's pronounced molybdenum. But everybody says Molly B. Denham when they read it, but it's pronounced molybdenum. All right, so its symbol is MO. And if we write it out, MOLYBDENUM. Okay, so that one will be hyphen notation, and this one will be the symbol for nuclear symbol. All right, so if we do the hyphen notation, what has to go after the hyphen? The mass or the number? So what was the mass? So we put the 92 there, and that one's done, because it only gets one number. How many numbers does the nuclear symbol get? Okay? Now, I will tell you that if you flip the numbers, I will not mark it wrong. Typically, the mass goes on top, but every now and then you will see some books that will flip them, but typically mass goes on top. So the 92 should go on top, and what should go on the bottom? The 42. But if you actually flip it, I will not get bent out of shape. Now, if you look at Molly B. Denham on your periodic table, what does the mass say?
95.94.
So it should really be about 96, right? My math say 96?
No.
Does that mean mine's wrong?
No.
No, it doesn't. Everybody got everything off the board? That's called an isotope. An isotope is an atom with the same number of protons, but a different number of neutrons. Now, that's the way a lot of books define it. You don't have to define it that way. How can we define it a different way? Well, what word today have we learned is the same as the number of protons? Think of a different word that we learned today. Atomic number. Okay, so they have to have the same atomic number, okay, but a different number of neutrons. So what is something that would be different that would account for a different number of neutrons that we've learned today? Yes. So we could have a different atomic mass. So I gave you MO that had 92, but the periodic table had 96. These would be what of each other? These would be isotopes. Now, one that you could relate to probably a little easier is this one. It's one that drives me nuts. Okay? What's carbon 12? Anybody know? It is. But all carbon. Half of y'all in here write with it currently.
Lead.
Okay. This is why it drives Miss Wall insane. Okay? Y'all are in chemistry class, right? All right. Let's have a conversation about this. Carbon. It's right here. 6 protons. Lead, stand here, it has 82 protons. Are these the same elements? Okay. Carbon be here, lead be here. Now, y'all are writing with pencils that have carbon. It's better known as graphite. Okay? It is a stereotype been perpetuated since the 70s. Lead is toxic. Okay? We took lead out of pencils back in the early 70s. Okay? Because let's just say I got pissed at Annette. And I took this lovely lead pencil. I jabbed it. And broke my lead point off in Annette. And we didn't fish it out. What's going to happen? You're going to get lead poisoning. Because of that, pencils are not made of lead any longer. Have not been since the early 70s. You are writing with a carbon pencil. You're not writing with lead. Have not been your entire lives. Your parents have probably not been writing with lead their entire lives. I'm 48 years old. I'm going to be 49 next month. I have never written with a lead pencil because I did not start school until 1976. Okay? Imagine that. So I know y'all have never written with a lead pencil unless you have found one in the archives somewhere. So y'all are writing with carbon. So when you turn to your classmate and say, can I borrow some lead? Y'all are not asking for lead, you're asking for graphite. Those are two different elements. So for the next 10 days have gone by, 80 days when you're in here, you need to learn to ask for some what? Graphite, some carbon. Do not ask for lead, okay? I will correct you, okay? After you leave my class and you want to ask for some more lead, that's fine. Even my own children at home have learned not to ask me for lead. All right? Yes, it drives them nuts, but they're going to learn, at least in my presence, not to ask for lead. So, you're asking for carbon. It's not lead. Nobody writes lead pencils. Drives me crazy when I walk into Walmart and it says lead. It probably says lead on that. It's not lead. All right? Carbon-14. What do we use carbon-14 for? Anybody know? I'm not talking about it in earth science. I hear that a lot. Think dinosaurs.
Oh,
Yes, we use it for dating, carbon dating. Okay? Okay, carbon-14 is radioactive, so we use it for carbon or fossil dating. Okay? One is plain old carbon. We use for pencils. It's very stable. We don't have to worry about it causing any issues. Carbon-14 is radioactive. We can use it to find out how old things are. Yes, ma'am. Of course you can. If you need tissue, just get up and get it. I don't want snot running down your face. It's very unattractive. It also embarrasses teenagers. So if you need tissues, you don't need to raise your hand. Okay? Questions? Now, let's see. Let's do this. No. No. All right, let's do that real quick. Let's do this, and then I'll talk about ions.
so why do people still say it and print it on packaging?
No idea. No idea. Because we don't use lead. We don't have, if, you'd have to have a really old house at this point to even have lead pipes.
Pardon the interruption. Teachers, just a reminder, please check your email and release those senior students as they are to be taking their pictures this morning. Thank you.
All right, have a question? Anybody have a question for me?
How do you find mass and you subtract them?
No. Mass is protons and neutrons. So it's and meaning math plus.
So what was the thing you don't have?
Protons and electrons.
Is that what you don't have? Because I remember you saying not to add something.
Yeah, protons and electrons. What you got a question? Is this supposed to be coming back to you? Anything?
Well, it makes sense.
Okay, as long as it makes sense, that's fine. I don't care if you don't remember, as long as it makes sense today. Anybody else have a question for me? Question on Elijah? You sure? Okay. Anybody else? Laser, you done? Anybody else have a question? Anything? ABL? Nothing? How many of us are still working? I got a couple. Okay. Give another minute or two. Then we'll go over what you got. All right, so if we look at the first, sodium has how many protons? How many electrons? I'm going to do protons, electrons, neutrons. So 11 electrons, how many protons? 12. Everybody okay with that one? Maybe I did it wrong in my head. I'm going to put the pen in my pocket. Sodium has 11. I thought it had 12 when I subtracted. Yes? No? Did I not subtract it right in my head? I said what had 12? Oh, okay. That's why. All right, so protons have, electrons have, and neutrons have. Maybe I should just write it. I tend to say it right. All right, protons have 29. Electrons have. Okay. Neutrons have 35. All right. Protons have. Electrons have. And neutrons have. Yes. We're all okay with those? And I tend to say it right, apparently, writing. All right. So, in the first one, we have what element? Silicon. You can say silicon or silicone. Either one is correct. And the mass would be, and the mass, or the number is. So, writing it out in hyphen notation, write out the word and what goes behind it. Everybody okay with that one? Can I erase? Okay. Number 2 here. We have what element? So, Fe, what goes at the top? 56, because we would add 26 plus 30 to get the mass, and then 26 down below. Iron, dash, what goes behind it? 56. Everybody okay with that one? Okay. And the last one We need the element. What would we find to be the element? Barium. All right. So BA, what is the mass? 138. And the atomic number is? So 138 behind this one. Questions about either of those two? Okay. So the last thing we want to do today is on ions. So ions are atoms with a charge. Now, charges can be positive or negative. So you could have an Na that has a +1, an O with a -2, an Al with a +3, an F with a -1. Okay? They can come in all varieties. Now, if you have positive and negative charges, they have names. A cation is a positive ion. An anion is a negative ion. Now, what does it mean to be a positive ion? A positive ion means that you lost electrons. A negative ion means that you gained electrons. Now, that often throws people. They're like, how can I have lost electrons and be positive? If you are positive, it means you have more protons, less electrons. That's why you're positive. Okay? You have more protons, less electrons. If you're a negative ion, that means you have less protons and more electrons. Okay? So that's why you've gained electrons.
But how does that work if they're supposed to have the same number?
That's why you're an ion, because you don't have the same number anymore.
They're not at
You're not an atom. You're not neutral anymore. That's what makes you an ion. You're no longer neutral. Okay? So when I say the word ion, you are not neutral. Okay? So now, when we count our protons, neutrons, and electrons, the protons and the electrons are not going to be the same. That's where we're going with this. Okay? Watch the video and catch up. I wouldn't even waste my time writing this down. I'd either get somebody's notes or I'd watch the video. All right. Has everybody got what they need? Tell me when you do. There? All right. So how is this different from a regular atom? Okay? Because Caroline said, I thought they were both neutral. All right? They're not going to be neutral. So let's say we take our friend iron, which we had just a second ago, with a 56 and a 26, only I write +3 this time. Okay? Now, this +3 right here tells us it's an ion. Now, it also tells us the protons and electrons are not equal. Okay? It tells us the protons and the electrons are not going to be equal. That's what that +3 up there tells us. Now, finding them, though, is not very difficult. So, how did we find the protons just a couple minutes ago when y'all all did it right? Okay, still the atomic number. Protons are the atomic number. So, what's our atomic number? Still 26. The electrons. What did we do just a minute ago? It was the same as the protons. Okay? So, same as the protons. So, that would be 26, right? Now, this is the new piece. This plus 3 right here means what happened? Plus 3 means what happened? We lost 3 electrons. Okay? That means we lost 3 electrons. So we are going to do what here with that 26? We're going to subtract 3 electrons because we lost 3. So we're actually going to have how many? 23. That's the only thing we do different with that plus 3. So how did y'all do neutrons just a couple minutes ago? You said what? I heard subtract. What, Sailor, what did we subtract? Yep, we still say mass, subtract number. So we still say 56 minus 26, which is 30. That doesn't change. So the only piece that was different is what to do with the what? That plus 3. And that plus 3 only affected the what? The electrons. The other 2 steps stayed the same. That did not change. Everybody with me on that? Can we do another one? Okay. Tell me when you got it. Anybody need more time? I don't hear any yeses out there. All right. Let's say that we do whoops, 34. All right. How do we find protons? All right. Is the atomic number, which would be what? 34. Okay, because that's the atomic number. All right. The electrons. How do we do electrons? Okay, it's the same as the protons. So we'd have 34. Okay. This right here means we did what? We gained 2. So that means we add 2 according to Chris. Do we agree with him? Yes. We gained 2 right here, which will give us 36 electrons. That is the only piece that changes in the whole problem. So the neutrons, we do the same thing as we've always done. So we do what to find neutrons? Mass minus number. So we get 75. Oops. 75 minus 34. 41. Questions about what to do with an ion? Yes? No? Feel okay with it? Yes? No? Think we can practice for homework? Okay, I got 2 minutes. I need 2 people to hand out papers for me. All right, the one that Angel is handing out has a chart. Here, Jim. The one that Angel is handing out has a chart. Okay? We're only doing 1 through 10 on the chart. Everybody hear me? Looks like this. I save paper. Do we know anything about average atomic mass and how to average with percents? Did I talk about that today? No. Leave that side alone. We don't know how to do it. We're only doing 1 through 10 on the chart. The one that Jada's handed you. All right? We're doing 1 through 9 odd. Okay? So, on the chart, 1 through 10, And 1 through 9, odd, on the ion page. Thank you, sir. So 1 through 10 on the chart, and 1 through 9, odd, on the ion page. Everybody got it? If you got your stuff, put your calculators up. So if you need grab and go, you can get down there and get in line and grab and go. Don't want anybody starving to death during the day. And remember, I'll be here Tuesday, Wednesday, and Thursday going to do test corrections. Or if you need to take the test. If you need to take it.
Malaysia Dill Day and Lauren Honeycutt, please come to the main office. That's Malaysia Dill Day and Lauren Honeycutt. Please come to the main office.
Oh, what's that? You know what Popeyes is?